Hello and welcome to this second installment of Turf Core Concepts, and this week we're going to look at a fertilizer calculator in Excel. So the best way to go through this, I feel, is to have a couple examples, and we're going to use the examples to work through this calculator and see how it works, and hopefully if you take the template, you'll be able to create the calculations yourself. And if you're interested in subscribing to the additional content that goes along with these videos, instructions to do so are included in the description of this video. So let's get going with our first example here. We'll look and we see a granular example with how many pounds of nitrogen, phosphorus, and potassium are there in a 2,000 pound parcel of a 23-3-15 fertilizer. And these problems are taken from the Mathematics of Turfgrass Management, and a link to purchase that book is also in the description of this video. So the first thing we're going to do is we're going to look at the calculator, and we're going to look at these cells that are highlighted yellow. These are all input cells. If a cell is not highlighted in yellow, it's a return cell with a formula already embedded in it. So the first thing we're going to do is we're going to look at the package. So this is for example, if you have a 50-pound bag, a 25-pound bag or something, but in this particular problem, we're just looking at a 2,000 pound, maybe a tote or something of fertilizer. So we're going to enter our 2,000 pounds in this cell, and then we're going to add our analysis here. So we have a 23, 3, 15 fertilizer. So now we look at this pounds of nutrient per bag. So these values here are calculated using the analysis and the package weight. So in this we have the 2,000. If it was a 50, these numbers would be different. So these numbers are calculated. You see B4, which is the analysis for nitrogen. Remember, in the analysis, the first number is elemental nitrogen, so there's no manipulation necessary there. So it's just what ends up being a factor here that creates your 23%. So you divide by 100 and you get 23%. You multiply it by the total amount that we're looking for. So in the 2,000 pounds of fertilizer, there are 460 pounds of nitrogen. Now we look at our phosphorus. So phosphorus in the analysis is P2O5. And in the supplemental material for this video, there's a little more about how to get to this factor of 0.44. But ultimately, in the molecule P2O5, 44% of that total weight in that molecule is made up of phosphorus. So that's why we multiply the middle number in the analysis by 0.44. And then we divide by 100 for the 3% by weight. And again, we multiply by the weight of either the bag or, in this case, a 2,000 pound parcel. And we find that we have 26.4 pounds of phosphorus in that 2,000 pounds of fertilizer. And then we do the same thing for potash, K2O. Except this time, instead of a factor of 0.44, we use a factor of 0.83 because in a molecule of K2O, 83% of that molecule is potassium. Do this, divide by 100, your 15%, multiply it by the 2,000, and we find that in that 2,000 pounds, we have 249 pounds of potassium. And if we look here at this slide, this is the dimensional analysis method if you were to do it by hand. And you see that when you do it the long way, you come up with the same answers as the Excel. So we're doing a good job so far. All right, so now we're going to go get a little more complex here with another granular problem. And this is problem 4.7 from the Mathematics of Turfgrass Management textbook. And we see here, there's a little manipulation that I made, but there are 3.68 acres of greens on the course, a total of 4 pounds of nitrogen per 1,000 feet squared. I use an M to indicate 1,000 feet squared units. All right, so if you see an M, that is shorthand for 1,000 feet squared. 4 pounds of nitrogen per 1,000 feet squared is to be applied during the season using 2210 fertilizer. The soil test also indicates that 3 pounds of potassium should be applied per 1,000 square feet per year. The question in this problem is how much additional potassium sulfate 0050 will be needed to achieve the 3 pounds of potassium level. All right, so what I'm going to do, let me first zero out from the previous example. Now, when this problem doesn't give us a weight per bag of fertilizer, so in situations like this package entry, you can just put 100 because these are percent by weight. So if your analysis, as long as you don't enter the analysis as a percent or a decimal, this 100 here will make the analysis the proper either decimal value or percent value in the rest of the sheet. Okay, so let's put in our analysis, 20, 2, 10. Now, before we go and look at the potassium, what we need to find out is how many pounds of potassium are applied through the applications to apply the 4 pounds of nitrogen, right? So we're going to enter this part of the sheet now where we're going to look at application area. So in the problem it says our application area is 3.68 acres of greens. And the way I have it set up, we already have conversion, so 3.68 acres is approximately 160,000 feet squared. That's what's given in the book. So you see there's a little bit of difference here from rounding and whatnot. So our answer is going to be slightly different than the answer in the textbook, but it's close enough to know that we're on the right track, okay? So now we look at our desired application rate. So we have the analysis of the fertilizer 2210. So let's just think about the nitrogen right now. So we go to the desired application rate, and we want to put 4 pounds of nitrogen per 1,000 square feet. Now we look at this, our calculator automatically sends us that we will need 3,206 pounds of product to achieve 4 pounds of nitrogen per 1,000 square feet. All right. And this bag's needed category is going to be based off this parcel number here. So I entered 100, so this is saying that we're going to need 3,200 pound bags to achieve this application. Now, I go down to this bags used tab, and I'm going to enter the number that's returned under the bags needed column. So it's saying we're going to need 32 bags. I do that, and you can check here. And if you apply 32 bags of this product, you will be applying about 4 pounds of nitrogen per 1,000 square feet. Okay, and that's 3,200 pound bags, so it's about 3,200 pounds of fertilizer. Now, what this check also returns is that in this 32 pounds of fertilizer that we're going to apply, we're also applying 1.66 pounds of potassium per 1,000 square feet. We know from the prompt that we are looking to apply 3 pounds of potassium, so we can simply do equal sign 3 pounds minus the 1.66 that we already applied, and we get 1.34 pounds of potassium still need to be applied to meet our the results of the soil test. So now what we're going to do, and we can check, in the PowerPoint supplemental to this video, the long form calculations are provided. So now we're going to go back to our calculator, and we're going to reset the calculator, this time for the potassium phosphate that's going to be used to supplement the potassium application. So we're going to keep the 100 the same. We're going to change the analysis input to 0, 0, 50. Okay. And look, our desired application rate, we're no longer really worried about nitrogen, obviously, because we don't have any in this product. So we'll put that to 0. And our desired application rate of potassium is the 1.34 pounds that we just calculated. So we'll enter our 1.34, and we're still applying this over the 3.68 acres of greens. And we look, and since we have zeros, we're getting error functions for potassium and nitrogen, or I'm sorry, phosphorus and nitrogen, so we don't really worry about that. And we just look at our final number here for potassium, and we see that to reach that 3 pounds of potassium per year, we will need to apply 518 pounds of the 0050. And we can again look at our bags needed. We see 5, so that's 500-pound bags, essentially 500 pounds. It's going to be a little less here because this would require a 5 pounds and a little extra, but I'm just rounding to this whole number, so you could even check in here with the 6, and you see that now you're applying about 0.2 of a pound extra per 1,000 if you were to do that. So it depends if you want to apply a little bit under your target rate or a little bit over your target rate. All right, so that's how you end up with the final answer of this problem is that you'll need 518 pounds of 005 to achieve the 3 pounds of potassium per 1,000 square feet per year. Okay, so let's just reset this all back to 0. And the last example that we're going to look at today is for a liquid fertilizer. So this same calculator can be copied into another sheet, and you just name this one liquid. And let me bring over my problem real quick. Okay, here's our liquid problem. The one difference between the granular sheet calculator and the liquid sheet calculator is the pounds of product turns into a pounds of product per gallon of product, because for your liquid formulations, you need to know how much 1 gallon of product will weigh before you can proceed with your calculations. But it's only one input that changes. Everything else is the same. You just have to know your pounds of product per gallon. So let's read this example. A 200-gallon sprayer is calibrated to release 3 gallons of total solution per 1,000 square feet. The goal is to apply a ½ pound of nitrogen per 1,000 square feet to 25 acres of fairway using a 16-2-3 liquid fertilizer that weighs 9.625 pounds per gallon. And we want to find how many gallons of fertilizer are needed for this application. So pounds of product per gallon is given as 9.625. Now we enter our analysis, 16, 2, 3, and desired application rate. We want to have ½ pound of nitrogen per 1,000, and we're going across 25 acres. And our answer, gallons needed, 354 gallons of product to achieve that rate of nitrogen over your 25 acres. And again, we have a check here, 354 gallons. We'll apply our ½ pound of nitrogen, and if the calculator is set up right, you'll automatically be given your rate of phosphorus, potassium, and also the total weight of phosphorus and potassium and nitrogen applied in the application. So I hope this is helpful, and if you would like to subscribe to these videos, a link is included in the description. I hope to hear from you soon. Thank you.